Epicon tutorial.
Good day, listeners. Today, we want to apply the method of Adomian decomposition to solve an initial value problem. So we start by writing the differential equation in operator form. So in operator form, the differential equation can be written as Ly equal to negative 3y prime minus 2y. L is assumed to be invertible, and because the differential equation we're solving is a second order, the highest linear derivative is of order 2, and so our L inverse is a two-fold integral operator. So that is, our L inverse is a two-fold integral operator, so which shall be applied. So we can then apply the L inverse to both sides. We're going to have L y equal to negative 3 L inverse of y prime minus 2 L inverse of y. So which results to negative 3 L inverse minus 2 L inverse y. So at this point now, we want to apply the initial conditions y of 0 equal to 1 and y prime of 0 equal to 0. So applying the initial conditions, we are going to have y of 0 plus x y prime of 0 minus 3 L y prime minus 2 L y. Then, by Adomian decomposition method, we can obtain the our equation can be written as follows. But before we do that, we would like to advise our listeners to watch our previous video on the analysis of Adomian decomposition method, and that will help a lot to understand this application. So we obtain the zeroth term as this y of 0 plus x y prime of 0, and this is our y of 0 is 1, and y prime of 0 is 0 from the initial conditions given to us. 1 of 0 is 1, y prime of 0 is 0. So as a result, y naught, this implies that y naught is equal to 1. This is the zeroth term. So the remaining part of the differential equations, this part shall be written as the recursive relation as y n plus 1 equal to negative 3 L inverse the y n dx minus 2 L inverse y n. So we shall then begin to simplify to obtain other terms. So at n equal to 1, n equal to 0, we are going to have y1 equal to negative 3 L inverse the y0, the y naught, the x minus 2 L inverse y naught. So we introduce our y naught here now, 3 L inverse d1, because our y naught is 1, the x minus 2 L inverse of 1. Differentiating 1 with respect to is a constant. When we differentiate it, we have it's going to be 0. minus, we are left with this L inverse of 1. So we should not forget that we are dealing with a second order differential equation. So our L inverse is a twofold integral operator. Therefore, it can be written as integral, double integral, like this, dx. So simplifying this gives 2 multiplied by x squared over 2. X squared over 2. And that gives us negative x squared. So our y1 is equal to negative x squared. Let's obtain the term when n equal to 1. At n equal to 1, we'll return to our recursive relation here. Yn plus 1 minus this. So when n is 1, it becomes y subscript 2 minus L inverse dy1 dx minus L inverse y1. So we write this one as y subscript 2 equal to negative 3 negative 2 L inverse y1. So if we introduce our y1 is negative x squared dx negative x squared. So this gives this becomes plus 3 L inverse. Differentiating this once, we are going to have 2x minus 2 L inverse into negative x squared. Or we say this negative cancels this negative sign. Now bringing in our operator. So we have 3 is a twofold integral operator. 2x dx plus 2 x squared dx. And so simplifying this will give us it will yield this will yield 6 times x raised to the power 3 over 6 plus 2 times x raised to the power 4 over 12. Simplifying this, our y2 will be x raised to the power 3 plus x raised to the power 4 over 6. So collecting all the results together, so we have our y of x is going to be y0 plus y1 plus y2. More terms can be obtained. So this will be 1 minus x squared plus x cubed plus x raised to the power 4 over 6. So which is the solution of the initial value problem. Thank you for listening.